Dear students, let's continue our practice on Mathematical Analysis 1, and we move to the new section, Improper Integrals. In this section, we look at a couple of different kinds of integrals, which call it improper integrals. And let's start with the first kind of improper integrals. So it's also called infinite interval. So in this kind of integral, one or both of the limits of integration are infinity. So in this case, the interval of integration is said to be over an infinite interval. So let's take one example, and then I will explain how to work with improper integrals. So, for example, evaluate the following integral from 1 till infinity, 1 over x squared dx. So let's consider this example. So here, as upper limit, we have infinity. Yeah. So, however, we have infinity, and it's not a real number. We cannot just integrate as normal. Yeah, and so how to integrate such kind of intervals? This is improper integral of the first kind. So we can change our upper bound, this infinity, with any t. So let's consider now our function f of x. F of x in this case it's 1 over x squared. So f of x on the interval, so in this case 1 and t, where t is greater than 1. So, and our integral now, we have integral, let's denote by I. So I t now depends on t now. So 1t, 1 over x squared dx. And now when we compute this integral, we have minus 1 over x, yeah, the primitive of this function, and 1t. So now it will be when we compute, so when we put t, it will be 1, so minus 1 over t, and when we put 1, 1, so 1 minus 1 over t. But this is not answer for our integral. Here we have t. Now we can get the solution on the interval 1 and infinity. So we need to take the limit of it. Yeah. So I, it's equals to limit of it. So it's not it here. Limit of it should be. Let me rewrite. I is limit of it as t goes to infinity. So we changed our infinity with t, which is goes to infinity. So, and now we need to find the limit here. T tends to infinity. 1 minus 1 over t here. And when we put infinity, it is 0. It is just 1. So the answer of our integral. So it is just 1 we have here. It's just 1. Or we can do it is easily in integral itself. So we can write like this: integral 1 infinity 1 over x squared dx. Yeah, so it's equals to limit t tends to infinity and the 1 t 1 over x squared dx, or limit t tends to infinity just without this notation. So minus 1 over t here, 1 and 1 over x here, 1t, and it will be limit t tends to infinity. So 1 minus 1 over t. So it's just 1. We can solve by this way also, without these notations. So we have two types of such kind of improper integrals. They may be convergent integrals or divergent integrals. We will call these integrals convergent if the associated limit exists and is a finite number. So if it's not, or we can say if it's not plus or minus infinity. And these integrals we call divergent if the associated limit either doesn't exist or is infinity, plus or minus infinity. So we have two types, convergent and divergent. Okay, so let me summarize. So the first case, let's give as definition. If a t f of x gx exists for every t is greater than a exists, like this we will denote, and then limit a infinity f of x gx, it's equals to limit t tends to infinity integral a t f of x dx. And the second case, provided the limit exists and is finite. This is exist and finite. So the second one, if there exists for every t less than b there exists integral t b f of x dx, then integral minus infinity b, it can be minus infinity in the least bound. So f of x dx equals to limit t tends to minus infinity t b f of x dx, provided the limits exist and is finite. And the third one is if two integrals, minus infinity till c f of x dx and integral c plus infinity f of x dx are both convergent, then integral minus infinity till plus infinity f of x dx equals to minus infinity till c f of x plus dx, of course, plus integral c plus infinity f of x dx. So we can divide where c is any number. Okay, let's consider the next example now. So, second example. Integral 1 till infinity 1 over x dx. Okay, so first thing we do is convert the integral to a limit. Yeah, so we have here integral 1, let's write just limits directly. Limit t tends to infinity, and here 1t 1 over x dx. Okay, so it will be limit t tends to infinity. This is natural logarithm, yeah, natural logarithm of x, 1 and t. So now it's equals to limit t tends to infinity. Here we have natural logarithm of t minus natural logarithm of 1. Yes. Now this is 0, but we have limit t tends to infinity, natural logarithm of t, and this is infinity. So the limits is infinite, and it means the integral is divergent. So we need to determine if the following integral is convergent or divergent, and if it's convergent, find its value. In our case, our integral is divergent, however we have infinite limits. So from these two examples, first example and second example, we'll get the next fact. So we have next fact. If a is greater than 0, then integral a infinity 1 over x the power of p dx is convergent if p is greater than 1. If p is greater than 1. And divergent if p is less than or equal 1. So we have two cases. If p, the power is greater than 1, this is convergent. If the power is less than or equal 1, it's divergent. In our case, we have p is here 1, so that's why it's divergent. We proved it. Okay, next example now. So, exercise number 3. Determine if the following integral is convergent or divergent. If it is convergent, find its value. Integral minus infinity till 0, 1 over square root of 3 minus x dx. Okay, so firstly, we'll again convert the integral to limit and evaluate the integral and then the limit. So it's equals to limit t tends to minus infinity, integral minus sorry, here just t till 0. However, this is least bound 1 over square root of 3 minus x dx. So the primitive of this function is just with minus 2 3 minus x square root of 3 minus x here we have. So limit t as t tends to minus infinity, so here we have minus 2 3 minus x and t 0. If we continue, we'll get here limit as t tends to minus infinity. So when we put 0, we have here just minus 2 square root of 3. When we put t, we'll get just plus 2 3 minus t. Yes, so it will be plus in the middle now. So now so t tends to minus infinity. This is plus in the middle, so it will be just minus 2 square root of 3 plus infinity we have here. So it's just infinity. So the limit is infinite and so our integral is divergent. Okay, next example. Example number 4. Determine if the following integral is convergent or divergent. If it's convergent, find its value. So integral minus infinity till plus infinity, x the power of e the power of minus x squared dx. So we need to determine it. Okay, so we can divide this integral by two integrals minus using the property, yeah, which I said. So 0, for example, x e the power of minus x squared. We can choose this point, any point. We choose here as x is 0, and I mean c this dx plus 0 infinity x e the power of minus x squared dx. Okay, so now let's consider individually two of them. So firstly, let's begin with this one, minus infinity till 0 x e the power of minus x squared dx. Yeah, okay, In this case, it will be limit t tends to minus infinity. Yes, again, integral t0. So the main idea in improper integral, one more time I will repeat, on the first kind of improper integrals, just change one bound if it is infinite. So change with limit. That's all. t0 x e minus x squared dx. Okay, now it will be limit t tends to minus infinity. In this case, we can move this x to the differential, and it will be x squared, but we have 1 over 2 integral t0 e the power of minus x squared dx squared we will get. And if you continue, we have here it will be equals to limit t tends to minus infinity, 1 over 2, but we have again minus e the power of minus x squared, and the t0 we have. Okay, so now it will be limit t tends to minus infinity, minus 1 over 2 plus 1 over 2 e to the power of minus t squared. Just putting values here. And however t tends to minus infinity, it tends to 0. And we get just minus 1 over 2. So we have finite value in our integral. So it means the first integral is convergent. No, it doesn't mean that the second integral will also be convergent. We need to check the second one also. Okay, let's check the second integral now. So the second integral is here, integral 0 plus infinity x e to the power of minus x squared dx. Okay, again we need to change our infinity bound with limit. T tends to plus infinity now. 0t, yes, x e to the power of minus x squared dx. And now it will be limit t tends to infinity. We did this integral one time, and we have minus 1 over 2 e to the power of minus x squared. 0, 1 we have. T, sorry. Zero t we have, and here we have the following integral now. So it's equals to limit t tends to infinity. It will be so minus 1 over 2 e to the power of minus t squared and plus 1 over 2 plus 1 over 2. So again it stands to 0, and we have just 1 over 2 when we compute the limit. So the second one is also convergent. So, and since they are both convergent, the given integral is also convergent, and its value is, now we need to add these two values, yeah. F of x is x e to the power of minus x squared dx. This is first integral equals to minus 1 over 2. The second one is plus 1 over 2. If we add them, it is 0. And its value is 0. And now let's continue. So let's consider the next example here. Find exercise number 5. Determine if the following integral is convergent or divergent. If it's convergent, find its value. So integral minus 2 infinity sine x dx. Okay, here firstly convert to a limit. It will be limit t tends to infinity minus 2 t sine x, yeah, dx. Okay, it's equals to limit t tends to infinity. So the integral of sine x, it is minus cosine x minus 2t. And now what we have here now limit t tends to infinity. And now we have cosine 2 minus cosine t. Yes? When we put t, it will be minus cosine t. When we put minus 2, however, cosine is even function, it will be cosine 2 plus, because in the middle when we have minus, double minus we have. So now when t tends to infinity, when t tends to infinity, this limit doesn't exist. This limit doesn't exist. And so our integral is divergent. Our integral is divergent. And now we'll talk about comparison test of two improper integrals. Okay, now let's give a theorem about comparison test. Let f and g integrable. So we denote integrability as Riemann, yeah? R on the interval a plus infinity. It means they are integrable on this interval. And be such that 0 f of x less than or equal g of x for all x from a plus infinity. Then we have this inequality less than integral a plus infinity f of x dx. Look here, they are integrable on the interval a plus infinity. Integral a plus infinity g of x dx. In particular, first case, if the integral of g converges, so the integral of f, so f also converges. Integral of of f converges. Second case, if the integral of f diverges, then integral of g also diverges. So if the bigger one converges, so it means the less one also converges. If less one diverges, the biggest one also diverges too. Okay. And now let's consider example. So discuss the convergence of the integrals 1 plus infinity arctangent x over x squared dx and example and integral 1 plus infinity arctangent x over x dx. Discuss the convergence of the integrals. So for all x from 1 till plus infinity, we have the following inequality: p over 4 arctangent p over pi over 2. It's true. So if we divide by x squared, this inequality, we have here arctangent x over x squared less than pi over 2x squared. Here we divide by x squared. And we have the next one. So pi over 4x less than or equals to arctangent x over x. Just divide by x. Yes? Now, hence we have the next inequality. Integral 1 plus infinity arctangent x over x squared dx. It's less than 1 plus infinity pi over 2x squared. And similarly, next one we have, so integral from 1 till plus infinity pi over 4x. We need to compare these two functions using this comparison test. Less than or equal integral 1 plus infinity arctangent x over x dx. Of course, here we have the x, here also we have the x. So now look these expressions. This is convergence. However, we have the fact if the power is greater than 1, it means strictly greater, yeah? It means it is convergence. So this is convergence. And this one is divergence. However, this is equals to 1, the power, yes? So we can compare these two functions now. Now, using this comparison test theorem, if greater one is convergence, it means the less one is also convergence. So it means this one is also convergence. And however, the least one is divergence, will be the greatest one also diverges. So it means this one is also diverges. So we have answer now. The integral arctangent x over x squared is convergence. Yes? It's convergence. This one is divergence. Using this comparison test, we easily define convergence of these integrals. And now let's formulate a next theorem about absolute convergence test. Theorem. So, suppose f is integrable. So Riemann, yeah, on the interval a plus infinity. F integrables is if this function is such that the absolute value of f is also integrable. On the interval a plus infinity. Then here locally, and then f is integrable. Then f is integrable on the interval a plus infinity, and moreover satisfied the next inequality. Integral a plus infinity f of x dx, so less than or equal integral a plus infinity, so absolute value of f of x dx we have. This test we call absolute convergence test. Let's consider one example again. Consider the following integral. 1 plus infinity cosine x over x squared dx. So let's use this absolute convergence test. Since cosine x over x squared, the absolute value is, however, the biggest value of cosine x is 1, it's less than or equal 1 over x squared. And now f of x is integrable on 1 plus infinity, it means absolute value. So what we have here? We have here the integral, I mean this absolute value, e plus 1 plus infinity cosine x over x squared dx. It's less than or equal, from this theorem, using this theorem, it will be 1 plus infinity cosine x over x squared, yes, dx. And using this inequality, we can change our integral with 1 over x squared. It will be less than or equal integral 1 plus infinity 1 over x squared dx. And the limit, if we find the limit here, let's find it. So integral 1 plus infinity 1 over x squared dx. It will be limit t tends to plus infinity. Here we have integral 1 t 1 over x squared dx. And it's equals to limit t tends to plus infinity minus 1 over x 1 t. It will be, so limit t tends to infinity minus 1 over t plus 1 plus 1. When t tends to 0, it will be 1. We did such kind of example in previous ones. So it is 1. It is 1. So this integral is 1. It means this, our integral is converged. And now let's consider the next example. Discuss the convergence of the improper integral. So integral, what we have here, so e plus infinity logarithm of x over square root of cubic root of x squared dx. Okay, so we need to find is it converges or diverges. And now, and how to define it? Again, we'll use this comparison test. Now, look here. So this is from e till plus infinity. It means our logarithm, the function cubic logarithm x over cubic root of x squared, the least value of logarithm here, it is logarithm e. Yes, because this is the least bound is e. If you put logarithm e, if you write just logarithm, it means natural logarithm. This is natural logarithm. If we don't have any base, it means natural logarithm. So natural logarithm of e, it's just 1. So it means this is greater or equal than 1 over cubic root of x squared. Cubic root of x squared. This is least value. And now, using the comparison test, which we showed, if the less one is diverges, it means the greatest one is also diverges. So it means our function, however, this is diverges because it is here the power is 2 over third. So the power of 2 over third, and it means this is diverges less than 1 because, yeah, from our fact. And least one is diverges, so it means the biggest one is also diverges. So this is diverges. Integral dx e plus infinity. So it means our integral is also diverges. Is also diverges. And now let's consider the next example. So determine if the following integral converges or diverges. If the integral converges, determine its value. Okay, so integral, what we have here, just a second. So minus infinity till 0, 1 plus 2x e to the power of minus x dx. So we can change our variable. So to integral to limit t tends to minus infinity, 1 plus 2x e to the power of minus x dx. So now can easily find here our integral. So it will be using the integration by part here. So let's denote by u 1 plus 2x, then du is 2 dx, and dv is e to the power of minus x dx, then v is minus e to the power of minus x. Now let's compute our integral. So it will be now minus uv minus e to the power of minus x 1 plus 2x, and the minus, but here we have minus again, plus integral. So it will be e to the power of minus x, we have 2 minus x dx. Okay, so it's equals to, but here we need to write limits over here. Yeah. So this is just, let it will be just integration of indefinite integral, and then we'll continue from this part. So here of course integral from t till 0. Okay, so now it will be e to the power of minus x. So when we open it, it will be 2 minus 2 e to the power of minus x. Yes, so it's equals to e to the power of minus x 1 plus 2x, and minus 2 e to the power of minus x. Yes, so and plus c when we integrate our indefinite integral. Let's do like this, yeah, and it will be e to the power of x factor out, and minus 3 plus, like, let's write here minus 3 plus 2x, it will be plus c constant any when we integrate indefinite integral. Okay, so integral e to the power of minus x 1 plus 2x dx, here dx it is. Okay, now let's put limit. Let's continue from this place. Limit, so limit t tends to minus infinity, and now this answer, yeah, so minus e to the power of minus x 3 plus 2x, and t 0. Okay, now it will be limit t tends to minus infinity So 3 plus 2t e the power of minus t minus 3. So when we put infinity, the answer will be here minus infinity. Minus infinity. So it means our improper integral is diverges. Integral is diverges. And the next time we'll continue improper integrals of second kind. And this example was the last example for today. If you have any questions, you can write on our discussion group. See you later. Thank you for attention.